Okay, boys, we're going to look at a new topic, the last topic for your course. It's called correlation and regression, and we're starting off with bivariate data. Now, bivariate data is just two different variables being compared, either graphically or in a table of values. Up to now, we've done univariate data, which just involves one variable. So, for example, if you listed a whole bunch of people's ages, that would be univariate data. Or you listed a whole bunch of people's heights, that would be univariate data as well. But if I'm comparing two variables, then I've got bivariate data. So for example, if I compare height versus arm span, okay, height versus arm span, two different variables, that's bivariate data. If I just looked at one of these alone, that would be univariate data. But when I'm looking at two together, that's bivariate. Income versus education level. Again, income is one variable, education level is the other. So it's bivariate data. Weight versus speed, also bivariate data because I've got two variables, weight and speed. Now, when we plot bivariate data on a number plane, we get a graph called a scatter plot. So let's have a look at what one of these looks like. So here we've got a table of values showing heights of people and their arm span. Okay, so let's have a look at this. Now, every dot represents a set of values from the table. So that first dot there, it's around about the 140-ish mark. Go back to the table, find that in there. That will be maybe about this one here, 142 and 141. All right, so each dot on the graph represents a set of coordinates from the table. Okay, so 142, 141 would be this one here. All right, so there's our scatter plot. All right, now we've got to describe this relationship as linear or non-linear. Now, linear means straight line and non-linear means not a straight line. So if we get a straight line and draw that roughly, so I've got maybe half the points above, half the points below, we could say that these points approximately follow a straight line. So the pattern of the scatter plot would be linear. So let's write that down for our first answer. So for the first one, we are going to choose linear. I'll just try that again. Okay, so answer for the first one. Here's the relationship, looks to be linear because most of the points lie on a straight line. Now, we've got to describe the relationship between height and arm span. Well, let's have a look. We've got height here, we've got arm span on the vertical axis. So as the heights increase, it looks like the arm span also increases. So that makes sense. As someone gets taller, generally their arms get longer. So for our answer here, let's just change the thickness to a little bit thinner. Okay, so we'd say as height increases, so as height increases, and then we'd say arm span increases. So the whole point of bivariate data is we're trying to see if there's a relationship between the variables. Okay, so in this particular example, we see the relationship is linear. We see that as height gets bigger, so does arm span as well. Now, the other thing to point about this graph is we didn't start at 0. If you don't start at 0, then we tend to have what we call a broken axis. Now, for a broken axis, what you're basically putting is a zigzag at the beginning here to indicate that you are not starting at 0. Okay, so and by not starting at 0, that gives us greater flexibility on how we do our scale. Okay, now let's have a look at dependent and independent variables. Now, when you've got two variables in bivariate data, we're looking to see which variable will depend on the other. So if we looked at the previous example about height versus arm span, would arm span depend on height, or would height depend on arm span? Well, arm span would depend on height, wouldn't it? So the taller you are, the longer your arms tend to be. So arm span is the dependent variable and height is the independent variable. The independent variable tends to go on the x-axis and the dependent variable goes on the y-axis. So if we just read through this together, the variable y depends on the value of the variable x, y is called the dependent variable, and x is called the independent variable. For example, stride length depends on the person's height. So stride length is the dependent variable and height is the independent variable. And when graphing, the dependent variable is shown on the vertical y-axis while the independent variable is shown on the horizontal x-axis. So if we try and simplify that idea, if you think about, let's just make up some equation, y equals mx plus b, typical straight line. Now, if I'm going to draw this graph and plot a table of values, typically I would do a little table and I would choose my x values, then sub the x values into this expression to get my y value. So I'm choosing the x values, which means they are the independent values, and the y values depend on what I choose. So the y is the dependent variable. You can also remember it quite often as the subject of the formula is the dependent variable. Let's have a look. We've got height and stride length measurements in a table, and if we think about which is x and which is y, we've got to think about which one is dependent. So does stride length depend on height, or does height depend on stride length? Well, I think stride length is going to depend on height. So stride length is your dependent variable. So if you like, you can say that's your vertical axis variable. And height is the independent variable. That's your x values, if you like. Okay. So stride length is the dependent variable in this one. So if I was to draw a quick sketch of the scatter plot to my number plane, the reason we need to know which one is the dependent and independent is because on the axes we need to know what the labels are. So the dependent variable goes in the vertical axis, so that'll be stride length, L in this case, L, and the independent one goes here for H. Okay, let's have a look at correlation. Okay, now for correlation, let's just have a check. Yep, that's all working. Okay, let's just hide that for a minute. Now for correlation, well, correlation is the strength and direction of a relationship between two variables. So the closer the variables are to forming a pattern, the stronger the correlation is. Now, when determining the direction of the relationship, we try and draw a line of best fit. So a line of best fit is what I drew before. It's a line which is approximately having half the points above and half the points below. If the line of best fit has a positive gradient, the correlation is positive. If the line of best fit has a negative gradient, the correlation is negative. There are three parts to describing the relationship. First of all, first part, is there a relationship between the points? So you can see here that really there's no relationship. I can draw a straight line if I want, but the points are all scattered. They're not following a particular pattern. So no correlation there. Here, there's a strong correlation because you can see the points follow a straight line. So I could draw a straight line here, and you can see most of the points here are basically lying on or near that line. And here, this is a weak correlation. So the points are near the straight line, but not many are on it. So it still does follow a pattern. It basically follows a linear pattern there. So strong correlation there and weak correlation there. Now, the next one is the direction of the relationship. If the points are going down from left to right, so in other words, when I draw my line of best fit, if my line has a negative gradient, then we say the correlation is negative. If, when I draw my line of best fit, the line has a positive gradient, then we say there's a positive correlation. Now, what type of relationship is shown? Well, there's the linear one, where the points lie on a straight line or they lie near the straight line. And then there's the non-linear one. Now, for the non-linear one, the points follow a curve pattern. So if we just have a look at this one, and let's have a look. So here we go. You can see that these points follow a curve and not a straight line. Okay, so let's have a look at first example. Describe the correlation between student heights and arm spans. So if we go back to the height and arm span data, which is back here. Here we go. We've got the heights and the arm spans. Now, the correlation is positive, isn't it? So positive correlation because the line is going up from left to right. We've got a positive gradient. And then you've got to describe this as a strong correlation or weak. It seems to be, well, I'd say probably medium. You've got a few points off there, but it's definitely not weak correlation. I'd say strong and positive. Strong and positive correlation. So for our first answer, we're going to write down strong, positive, and linear. So three things you've got to consider: the strength, whether it's positive or negative, and whether it's linear or not linear. Let's have a look at these ones below. You can pause the video now and have a go at these questions by yourself. Describe the correlation of the relationships between the two variables in the scatter plot shown. Okay, so the first one is, I'd say, no correlation. This is weak. Well, no correlation. No correlation. Right? Or possibly, yeah, maybe we'll change that. We'll change it. I think they are quite far apart, but it does seem to be going up, doesn't it? So if you drew a line of fit, they are approximately following that line. So let's change that from no correlation to a weak correlation. So yeah, that's a weak one. So weak, linear, and positive. Okay, weak correlation. I'll just rub this out here. Weak, linear, and positive. Let's look at the next one. So this is, if we draw a line here, this would be going down from left to right. This is a very strong correlation. You see all those points lie on the same straight line. So strong, negative, and linear. Okay, this one here, no correlation. No correlation. Okay. Now, what about the next one? Well, if I drew my line of fit here, let's just draw that in. A line of fit, here it is. All those points lie pretty close to the line. So, and because they lie quite close to the line, I'm going to say that those points are strong. So strong correlation. Linear and negative. Next one. Well, all these points lie on the same straight line, don't they? Okay, so this is another strong correlation. So strong, linear. But the gradient of that line is positive, so it's positive. And this one here, this is the opposite of the first example, basically, isn't it? You've got some sort of straight line going through here. So we'll say it's a weak correlation. It's linear. The line is a negative gradient, so negative. Okay. All right, let's move on. Now, the heights and handspans of a group of students are shown in the table. Plot the data on a scatter plot. Describe the pattern of the plotted points and describe the relationship between the students' heights and their handspans. Now, when you do this, you are going to have to decide on what numbers go on the axes here and which numbers, which variables go on the vertical axis, and which variables go on the horizontal axis. Now, first of all, let's see which is the independent one and which is the dependent one. Now, does height depend on handspan, or does handspan depend on height? So the taller you are, normally the bigger your hands. So handspan will depend on height. So if you like, we'll have span or S span there, and the height will be over here. Okay, now you've got to decide which numbers go where and where you're going to start. So let's have a look at the numbers here, and also I'm just going to label this X and this Y. So the Y variable is the dependent variable and the X is the independent. That'll help you when you're plotting your points. Now you can see here that 156 is the smallest for the height and 185 is the biggest. Okay, so when I go down to the height axis, I'm going to start at 155. I might actually start here on the big tick mark. 155, 160, 165, 170, 175, 180, 185. Okay. Now technically I didn't start at 0, so I should do some sort of zigzag here to say that the axis is broken. All right, now let's have a look at the next one, which is The handspan. Now, let's have a look at the smallest one. The smallest one for the handspan is 16.5, so just here. And the largest is 25. So on my vertical axis, I'm going to come down here and I will start at 16 as my lowest. And then the next big tick mark is 17, and 18, 19, 20, 21, 22, 23, 24, and then 25. Okay. Now, after I've done that, I've got to plot the points. Now, just to save a bit of time, I've already done that. Pause the video now and have a go yourself. Okay, so here's my scatter plot. I've plotted all those points there. So that's that there done. You can check your answers. And so I've done part A, plotted the data. I've just described the pattern of the plotted points. Okay, so let's have a look. So I'm just going to get my line tool and let's just draw a line of fit. I'm going to try and get maybe approximately half the points above and half the points below. So 1, 2, 3, 4, 5, 6. 1, 2, 3. Yeah, maybe that's about right. It's just an estimate. You can see that my points follow a line with a positive gradient. So I'm going to say that the relationship is positive. I am going to say it's a weak relationship because the points are quite far away from the line there. So weak relationship and positive correlation. So let's write that down. Now, there was 3 things we had to do, wasn't there? 3 words. So we're going to say weak, we're going to say linear, and we're going to say positive. So weak, linear, and positive for the second point there. Okay, so let's write that down. So weak is linear, and it's positive. You might argue that maybe it's not so weak, maybe the relationship is medium. It's a bit silly to have just a choice between strong and weak. We'll get into more precise descriptions later on in the chapter with numbers. Now, describe the relationship between the students' heights and their handspans. Well, generally, as the height, if you look at this, you can see as the heights increase, so do the handspans. Okay, so in general. So not for all cases, but in general. So we'd say as heights increase, so as height increases, handspan also increases. Okay. All right, so that's scatter plots. Let's move on to something called causality. Now, you might get some variables with a very strong correlation, okay? But it doesn't mean one variable causes the other. It doesn't mean that one variable influences the other, right? Which means we can't assume causality. So, for example, if you did a scatter plot of left foot size, so left foot size versus right foot size, most people have feet which are the same size or very close to the same size. but you wouldn't conclude that the left foot size influences the right foot size or vice versa. So there might be a strong correlation between their variables, but it doesn't mean that one variable influences the other. So you've got to be careful there that you don't always assume causality. Okay, so let's have a look at an example. For each set of this bivariate data, find which ones have a causal relationship. Now, the number of people in a family and the number of TVs, does one cause the other? So if I've got 5 people in my family, does that cause me to have 5 TVs or 1 TV? I'd say no causal relationship there necessarily. Okay. No causal relationship or a limited causal relationship. Speed of the boat and time taken to travel across the lake. Well, generally, the faster you go, the less time it takes. So that's definitely a causal relationship. Okay, so causal relationship. One causes the other. Okay, causal relationship. You can't definitely say that the number of people in the family causes the number of televisions in the household. So, or you couldn't say the number of televisions causes the number of people in the family. So you've got to be careful there, but there's a causal relationship in the second example there. Okay. Now, moving along to our line of best fit here. Now we're going to practice drawing lines of best fit. Now, when completing a scatter plot, the data may approximate a straight line. In this case, we draw a straight line as close to as many points as possible. This is called the line of fit or line of best fit. There's some general guidelines to drawing a line of best fit. First of all, the line goes through as many points as possible. Okay? And the line has roughly half of the points above it and half of the points below it. It is drawn so that the distances between each point in the line are as short as possible. And because we're drawing a straight line, the equation of the line of best fit is of the form y equals mx plus b, where m is the gradient and b is the y-intercept. Now, we've already drawn a scatter plot, so we're not going to do that again. We've got a table of bivariate data that's been plotted. What I'd like you to do is to pause the video now and on your notes, try and draw the line of best fit. Remember, you're trying to have approximately half the points above and half the points below, and the line should be going through as many points as possible. So 1, 2, 3, 4, 5, 6, 7, 8. There's 10 points there. So pause the video, have a go, and then check the answer. So we got there 1, 2, 3, 4, 5, and then 1, 2, 3. That'll do. Okay. You don't have to start from the first dot. I did. You're just aiming to have roughly 5 above and 5 below. So yours might be slightly different to mine, but when you're doing this by eye, you're just estimating. So there's a line of best fit there. Okay. Now let's get on to something called interpolation and extrapolation. Now, we can use that line of best fit to interpret the results. Now, we can predict what might happen using that line. So if we read the data on the line between points on the scatter plot, and it's within the range of the data, this is called interpolation. And if we look beyond the data points by following the line of best fit, this is called extrapolation. Extrapolation is when we're reading data from the line of best fit outside the range of the data. So let's have a look at the first example. Here's a line of best fit in our scatter plot. Use a graph to interpolate the foot size of a year 10 student with an arm span of 185 centimetres. Okay, so if we go to 185 centimetres, so what have we got here? 2, 4, this is going up by 2, so We're going to go up roughly to there, and then we're going to go across from there to read off the corresponding value. Okay, just estimating. Now, the reason this is called interpolation is because you notice that where I've landed, let me just get a different color here. This is the point that I'm reading off here on the line. Notice at that point there is between two of the data points that have been plotted already. Because it's between the data points, this is called interpolation. Okay, so for 185 centimeters we go, and that is a right foot size of 22, so about 28 centimeters. Okay, so for that answer there, I'm going to say 28 centimeters. So that's an example of interpolation. So interpolation is using the line of best fit, right, to read off data between data points which have been plotted. Now, extrapolation, let's do that next. Use the graph to extrapolate the arm span of a Year 10 student who has a foot size of 31 centimeters. So let's just go back to the line tool, and let's choose a different color this time. Now we're going to go to 31 centimeters. So 31 centimeters is approximately here. So we're going to go across. There we go. Maybe I should use a different color for that one. Let's change that. We'll just use black. Okay. Make that a bit thicker. So starting from here, there we go. And then from now, we're going to go down to the vertical axis, the horizontal axis. So down vertically, so around about there roughly. That's my estimate. Now, this is extrapolation, and the reason it's extrapolation is because if you look at the point on the line of best fit that I'm reading coordinates from, this point here is beyond the plotted data points from the table. So it's beyond the range of data. So this is called extrapolation. So that's 200 centimeters for that answer. So when you're reading data on the line of best fit beyond the data points which have been plotted, right, and it's not between the data points, and that's called extrapolation. But if you're reading data on the line of best fit between the plotted data points, that's called interpolation. Okay, so you've got to be clear on that definition. And that is our lesson.